Welcome to the introduction of blockchain systems. In this video, we're going to explore the fundamental concepts of blockchain technology, focusing on distributed ledgers and cryptocurrency architecture. Let's dive in. So, what exactly is a blockchain? At its core, a blockchain is a distributed digital ledger. This ledger records transactions across many computers, making the information stored on it virtually impossible to alter or delete, which we call immutable. This also ensures transparency, as all participants can view the recorded transactions. Blockchains have several key characteristics. First, they are immutable. This means once data is recorded, it cannot be altered or deleted. Second, blockchains are decentralized, meaning that there is no single point of control or failure. Third, they are transparent. All transactions are visible to network participants. Finally, blocks are cryptographically linked together using hash functions, ensuring the integrity and order of the data. Let's break down the structure of a block in a blockchain. Each block consists of two main parts: the block header and the transaction data. The block header contains critical information, including the hash of the previous block, often called previous hash, a Merkle root that summarizes all the transactions in the block, a timestamp indicating when the block was created, and a nonce, which is a number used in the mining process. Following the arrow, the transaction data section contains a list of all the transactions included in the block, such as transaction 1, Alice to Bob, transaction 2, Bob to Charlie, transaction 3, Charlie to Dave, and so on. Cryptographic hash functions are a vital component of blockchain technology. Let's explore how they work. On the top, we have the secure hash algorithm 256 hash function, also known as SHA-256. If we input the words "Hello World," the function outputs a long string of seemingly random characters and numbers: a 591, a 6D40, BF42040, a 011733, CFB7B190, D62C65, BF0, BCDA32, B57, B277, D9A, D9F146E. Now, if we change the input even slightly, like adding an exclamation point to "Hello World," the output changes completely to 7F83B165, 7FF1FC5, 3B92DC18148, a 1D65DF C2D4B1F3D677284ADDD200126D9069. This is important because it means that even a small change to the data will result in a completely different hash, ensuring the integrity of the blockchain. Consensus mechanisms are the methods by which a blockchain network agrees on the validity of new blocks. One popular consensus mechanism is proof of work, where miners solve complex computational puzzles to validate blocks. This method is known to be energy-intensive but is also very secure. Another one is proof of stake, where validators are chosen based on their stake or holdings in the network. This is considered an energy-efficient alternative to proof of work. Let's visualize the architecture of a distributed ledger. In a peer network, we have multiple nodes, in this case node A, node B, and node C, all interconnected. These nodes are synchronized, meaning they all maintain a copy of the blockchain. Because of this, they are all decentralized. Cryptocurrency architecture can be viewed in layers. At layer number 1, we have the application layer, which includes wallets, exchanges, and smart contracts. Moving to layer number 2, we have the protocol layer, which defines the blockchain rules and consensus mechanisms. Finally, at layer number 3, is the network layer, which is the peer-to-peer communication infrastructure that allows the nodes to communicate. Let's walk through the transaction flow in a blockchain. First, a user creates a transaction. Second, the transaction is broadcasted to the network. Third, nodes on the network validate the transaction. Fourth, and finally, the validated transaction is confirmed and added to a block in the blockchain. Finally, let's consider the security features and key challenges of blockchain systems. Key security features include cryptographic integrity, distributed verification, and immutable records. However, blockchain also faces key challenges like scalability limitations, high energy consumption for some consensus mechanisms, and regulatory uncertainty. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.